Hello everyone, welcome to Dr. Raja Gate Lectures. In this session, we will discuss about random process, which is very important if you're talking about GATE examination point of view. At least you will get one question from this particular topics, right? Now let's start with what is the random process. Random process. Before dealing with random process, in the first video lecture, I have already described about what is the random variable. Random process is nothing but a extension form of what is random variable. So let me remind you what is random variable. Random I think you might be understood about what is random variable. So let me remind you, random variable, it is what? It is a real value function, real valued function that's assigns what? Number of outcomes of sample space as in the random experiment. So we can say that random variable, it is denoted by x, is what? Is a function of what? The outcomes, where lambda is, I have denoted it what? Random, this is the what? Outcomes, and is it also called as what? Sample points. Right, we have already discussed in the first video lecture, right? So random variable, is a function of what? The outcomes. Now coming back to the what is the random process, it is just extension of what is random variable. Random, then what is a random process? Random process is a random variable in which it's a function of time as well as what? The outcomes, right? In the random variable, it's a function of the outcomes. In the random process, it is time as well as is a function of the time as well as what? Outcomes. So we can say that. What is the random process? So it is what? It is a real valued function. It is a real valued time function. Time function, because we have already talked about random process. It's depend upon what is the time as well as what is the outcomes. That's assigns what? Number of outcomes of sample space S in the random experiment. Right? So we can say that random process is a function of what? Time. It is just denoted by, if random process is denoted by x of t, is what? Is a function of what? Time as well as this is the outcomes, right? This is what? Outcomes. This one is what? So we can say that random process is a function of two parameters, that is, one is time and second is was outcomes, right? So as I'm just taking about what is the at the point of time. This is what? For time t1, this particular time, if x of t is what? X of t1 is what? This is what? Random variable. For t2, x of t2 is what? it is also random variable up to so on. So we can say that it is a random variable. Random process is a random variable which is depends on the time also, right? Now for specific value of what, for fixed value of lambda j, I'm just talking about what is the lambda j. This is the fixed value of lambda j is what, x of t. Lambda j is nothing but what, xj t. This is what, this is sorry, small of x of j. This is what, this is a variable. This is what, time function which vary with respect to time function, which vary with respect to time. Though this time function is called as what, this time function is called as sample function. This time function is called as time functions, and this collection of the time function is called as ensemble. I'll talk about it. For fixed value of lambda j is what, nothing but x of t minus lambda j, nothing but xj of t is what, time function which is called as sample functions. What about for fixed value of time? Fixed value of time, that is what, ti is nothing but x of t I. Lambda is what, x ti. What is this? Is what, random variable which is a function of what, which is a function of time. Is a random variable for particular time. For time t1, x of t is what, x1 t, and for t2 x of t becomes what, t2. This is what, random variable, right? If what happen if both will fix, if both value of, if you're talking about time as well as the outcomes, for both fixed, for both value of the for both fixed, that is ti and lambda j is what, that is what, x ti comma lambda j is nothing but, this is what, x j ti. This is what, numbers. This is numbers, right? So by the graphically, how can we understand what is a random process? So how can we understand what is a random process? By the graphically, as we have already talked about, at the fixed value of lambda j is what, xj of t, which is what, time functions which is called as what is a sample functions. Now suppose we have a sample space, that is what, lambda 1, lambda 2 is what, this is, you can say that this is the outcomes. This set of the outcomes is called as what, the sample space, and I'm just taking a time functions which is vary with respect to the time. Suppose I'm taking a time functions which is vary. This is what, if outcomes is associated with what, for particular value of this lambda 1, this x1 is what, a random variable with respect to it's vary with respect to what, the time. It is what this is the what, outcomes of first trial, right? This is the outcomes of the first trial. What about for lambda 2, it is nothing but I'm just taking it right. This is outcomes of second trial. This one is first trial, and this one is what? Second trial, and I'm just last one is taking what? Nth trial. This is what that outcomes of nth trial, right? This is the this is what x2t, this one is what x and t, right? So as I'm taking 2 time of slot, that is what this one is what I'm just taking it 2 time of slot. This is what t1, and this one is for t2. I am considering 2 time of slot t1 and t2, right? At this point of time, what is x1 t1, and this is what at this point, this is what x1 t2 you will get. And what about this one? This one is what x2 t1, and at this point what is x and t1. At this point you will get what? x2 t2, and at this point this is what? x and t2, right? This at this point of time, this is what? x1. So as you can say that at this point, this is what? x1, which is nothing but random variable x of t1 lambda, and at this point is what? Random process x2 t2 comma lambda is what? x t2 x2 is what? Random values. These are the random values. This one is what? Random values. x1 and x2 is what? Random values. So this is how we can understand what is a random process, right? So I hope you might be understood this concept, what is the random process. And we by the mathematically I have described about taking the time slot t1 and t2, a random process which is associated with how associated with of the outcomes, so in the sample space. So I hope you might be understood this concept properly. Now next heading is what? The distribution and density function of random process x of t, right? So in this, so we have to discuss what is the distribution and density function of random process x of t. So as you know about that, x of t is what? Random process for particular time, for this point of time t1. X of t1 is what? A random variable, right? So this is what? X of t1 is what? Random variable. So density distribution function is what? Is denoted by x of t1. x1 is what? Probability is, it's give the probability if random variable x of t1 less or equal to x1, right? It's for particular time of t1. Let random process is at the time t1 is what random variable. Then what is the distribution function of this random variable is what it's give the probability if random variable x of t1 less or equal to x1. So what about the distribution functions, which is denoted by what? F of xt1. x1 is what? Just taking the differentiation with respect to what? x1 of what? F of x1 is x1. This is what? This is distribution function. This is which the order of is what? First order distribution functions. So it is also called as this density function is what? First order density function. This is what? First order density function, right? Now we are taking 2 point of time. We are just taking for, we can say that for t1 is what? xt1. For t2 this random process becomes xt2 as what? Random variable, right? Then what about distribution functions corresponding? What about the distribution function is what? F of x t1 x t2 x comma x1 comma x2. It's give the probability. This is what? The probability. It's give the probability if random variable x t1 less or equal to x1 comma x t2 less or equal to x2. This is what? Second order. This is what? Second order distribution function, because we have two random variable, so it is called as second order distribution functions, or we can say that joint distribution function, right? And correspondingly we can find out, we can determine what is the density functions just taking the x t1 f of x t1 x t2 comma x1 comma x2 is nothing but just taking the 2 times differentiation with respect to dx1 dx2 what? F of x t1 x t2 x1 comma x2, right? And what about nth order distribution functions? If you are taking the time instant up to tn, now tn is what? So we can generate t1 for t1 t2 and tn. This is what? Up to what? X of tn. Random variable becomes x of t1 tn x of, sorry, I'm taking this x of xn, right? And this is what? X2. This is what? X of 1. So this distribution becomes what? For nth order we can write like that: f of x1 x2 up to xn for nth order. So we can say that x1 comma x2 comma xn, right? It's nothing but it's give the probability if random variable x t1 less or equal to x1 or random variable x of 2 less or equal to x2 up to random variable x of n less or equal to x n. This is what? Nth order of, this is nth order of what? Distribution functions. And we can also determine what is the corresponding density functions, right? Now next point is what? Statistical average. Statistical average, right? For random variable x, let x is what? Random process, right? Now the first statistical average is what? Mean. Mean is what? Nothing but it's give the what is the expectations of x of t, right? Is what? Nothing but x f of x dx minus infinite to plus infinite, right? Right. So this is for all value of t. And second statistical average is what? This is first this is mean, and what is what this autocorrelation. Autocorrelation of x of t. This is autocorrelation of x of t. For particular time t1 is what? X of t1. This is x. For t2 is what? X of t2 is what? Random variable. So autocorrelation is what? It is denoted by it is denoted by r x t1 t2, because we are taking two time of instant, that is t1 and t2. So or x of t or x t1 comma t2 is nothing but it's what is the expectations of x t1 and multiply with x2, right? Which gives nothing but x1 x2 f of x t1 x t2, right? Which is nothing but x1 x t2, right? x1 comma x2, right? If we are taking the difference integration minus infinite to plus infinite, x1 with respect to x1 and x2, right? This is what? This is the autocorrelation of x of t, which is we are taking two time of instant t1 and t2. Correspondingly we will get what is the random variable of this particular time of instant t1 and t2, and correspondingly we will get what is the autocorrelation of x of t, right? X at the t1 and t2, you will get this is nothing but x of t1 x of t2, just multiply with expectation of x of t1 and t2, which is nothing but x1 x2. Just take that integration with respect to x1 and x2. What is the third is what? Third is what? Covariance. Autocovariance. Covariance, which is what? Denoted by cx t1 and t2, which is nothing but what? Expectations of what? x t1 minus mu x t1. This is the what? Mu x t1 is what? The first that is the mean value of random process, random variable x of t1, right? Just multiply with x of t2 minus mu x of t2. That is what, this is the first, that is mean of what, random variable x of 2, right? If you are taking the multiplication, you will get this, the autocovariance, as you can say that this is what mean of random variable x of 2, this one is what mean of random variable x of t, right? This is what random variable x1, xt1 and xt2. Just multiply. If you are multiplying these value, you will get what? Just multiply. This is xt1 multiply with xt2 and minus expectations of xt1 multiply with mu x t2, right? And this one is what, minus mu x t1 multiply with x t2 and minus plus mu x t1 multiply with mu x2, right? Just we have to take the, so as you know that mean is what I have denoted is, what is the mean value of x of t is what, mu x of t, mu x, that is the mean of this random process x of t, right? So after it is, as you know that expectations is what, linear operator, so it can be performed in the inner part of this bracket. So it is we can written like that, expectations of xt1, just expectation of xt1 xt2, right, minus it is what, because this is the random variable, so this is, if you are taking the expectations of x of t1, what this is, if you are taking the expectation of xt1, that is what, mu x1 mu x of t1 and multiply with mu x of t2. And what about this one, if you are taking the performing the expectations, you will get what, mu x t1 as it is, this is what mu x t2 you will get, and because this is the constant value, so you will get what, mu x t1 mu x t2, because this will cancel, so you will get what, expectations of x t1 multiply with expectations of x2 minus mu x t1 and mu x t2, you will get these value. So as you know that expectations of xt1 and xt2 is what, this is what autocorrelation of t1 and t2 minus mu x t1 and mu x t2, right? So this is all about statistical average. Now next point is what, stationary process. Next point is what, right? So it is divided into two parts. First is what, strict sense sense stationary process, and second part is what? Wide sense stationary process. Wide sense stationary process, SSSP, and what is this one is for WSSP, wide sense stationary process. I am just talking about random process x of t. I am just taking the consider it what is the random process x of t is what? Random process. What is the condition of random process is to be strict sense stationary process and wide sense stationary process. We will discuss, right? So for the stationary process, all the statistical average, that is what? Mean, variance, and mean square value is what? Independent of time. It is what? Independent of time. It does not depend on the time. If random process, if you are taking the mean, variance and mean square value, this is the statistical average, is independent of the time, then the random process is said to be stationary, right? It is divided into two parts, that is first strict sense stationary process, second one is what? Wide sense stationary process. And in the stationary process, it is what? If random process x of t, it's what? It's statistical. It's statistical. It is statistical is what? Is invariant to a shift of origin. It is, if it's statistical is invariant to the shift of the origin, then random process x to be what? Statistical strict sense stationary process. What about this one? If random process x of t, for random process x of t, if mean is what? Mean, that is what? Mean will be constant. It does not depend on the time. If mean is constant of this random process, is called the first condition of is said to be wide sense stationary process, and second condition is that autocorrelation, that is autocorrelation is what? It's autocorrelation depends on what? Depends on time difference. Time difference. I am talking about what? Before that, if we are taking t1 for this particular time, this is what? Random variable x of t1, and for t2 random variable is what? X of t2. If for x t1 comma t2 is what? If this one is depends on what? Or x t2 minus t1, that is what? The time difference, that is the meaning of the time difference, because it is depends on the time difference. If this autocorrelation depends on the time difference, it x of t holds this condition. If x of t hold this condition, that is the mean will be constant, and autocorrelation is what depends on the time differences. So x of t is what is said to be wide sense stationary process. If these two condition holds, then x of t is what is said to be WSS random process, wide sense stationary process, right? What is the meaning of what is the statistical invariant to the shift of the origin? We will talk about what is the condition of the strict sense stationary process to be satisfied. We will discuss it is separate. So I am just talking about it is, we have already discussed in the what is the condition of the wide sense stationary process. Now I just want to discuss it separately. What is the condition of strict sense stationary process? Strict sense stationary right, SSSP. Let what random, this is what random process. I am just talking about what for time, for set of the time, this is what t1 t2 up to tk. I am just taking is what this particular of the set of the time, this is what the random variable is what xt1 comma xt2 up to xtk. These are what random variable, right? Correspondingly, what is the joint distribution function of this set of the random variable? So how can you get it? What is the distribution functions? F xt1 xt2 up to xtk, right? xt1 sorry x1 x2 up to xk. This is what distribution functions. I am taking what I am just going to satisfy what I am going to discuss the conditions so that x of t is said to be strict sense stationary process. Now I am just taking a concept, this is value, this is the fixed amount, this is the value of the fixed amount. I'm just going to shift of this random process, this random variable. I'm just going to this amount to shift of this set of random variable. That is what will happen if you are shifting of this amount. This is what xt1 plus tau comma xt2 plus tau and up to xtk plus tau. And what is the correspondingly this joint distribution functions? So we can say that of this set of the joint distribution functions of distribution function, how would you get it? This is what f x t1 plus tau x t2 plus tau up to what x tk plus tau. This is what x1 comma x2 up to x what xk, right? This is what, this is the joint distribution functions of this shifted amount of this is what tau, and it has to be what, it has to be right f of x t1, f of x t2 up to x of t k, x1 comma x2 comma xk. It should be invariant. If you're shifting the amount of what is tau, it has to be invariant. Then the random process, if this condition holds, what will happen? Then x of t, the random process x of t is what is said to be strict sense stationary process, right? Now if you're talking about the value of k, what will happen if I'm just taking the value of we have a time slot set of the time, that is what t1, t2, tk. I'm just taking the k value of k is what? I'm just taking the value of k is equals to 1. What will happen? So correspondingly, what is the random variable? X of t1, x of t2 up to x of tk. I'm just taking k value, k is equals to 1. That means I'm just talking about this one. So random variable x of t, t1 for this one t1, random variable x of t1, what is the distribution function is what? X of t1 x1, right, is what? Equal to fx t1 plus tau x1. This is what, if you are taking at this point of time, if it's independent of the time, that is what? Fx x, right? This is what, if this holds, it has to be hold for x of t is what? Wn for ss strict sense stationary process of x of t, right? It has to be invariant and it's independent. That is what I'm just talking about, independent of time. The first order distribution functions is independent, does not depends on the time for the strict sense stationary process of x of t, right? I'm just considering it what about happen if k value of k is equals to 0. That means f of x t1, f of x 2, x1 comma x2 is equals to what? F x t1 plus tau. What is the variant? This tau is the amount of the this is the fixed amount of variant of the t1, and x t2 plus tau. This is what? x1 x2. If taking t1 plus tau will be 0, then value of tau is what? Minus t1. So we can say that fx 0 and x t2, just putting the value of tau, you will get what? t2 minus t1, x1 comma x2. For value of two random variable x of t1, x of t2, for this is what this is what t1 minus t2 is what? It depends on the distribution. It depends on what? The time difference. This is called as what? The time difference. Right? For SSP of x of t. If you are taking two random variable x of t1 and t2, you are taking the invariant, it's depend on the time difference. That is what? T2 minus t1, right? So if this condition holds, this is what x of t is what strict sense stationary process, right? Now what WSS, wide sense stationary process. As I said, for random variable x of t is said to be stationary process if this is what random process x of t is said to be a stationary process. It holds two conditions. First condition is what? If expectations of x of t is what? That is mean. Is what? Independent. Is independent of the time, that is what? Constant. What is the constant? That is independent of time. And second condition is what? If for random variable x of t, for t1 is what? X of t1, and for t2, these two random variable x of t1 and x of t2, then autocorrelation is what? X autocorrelation, that is what? Or x t1 comma t2 is nothing but what? Expectations of x of t1, x of t2 is what? It's depend on the what? Time difference, or x of t2 minus t1. I am just taking t2 minus t1 is what? A new variable, that is tau. So our autocorrelation x of t1 comma t2, it's depend on what? Or xx tau. So this, if random process holds these two conditions, that is what? Constant, mean value will be constant, independent of the time, and autocorrelation, this is what? Autocorrelation, it's depend on what? Depends on time difference. If this two condition holds, that is what? This x of t, this random process is said to be wide sense stationary process. Now note, ASSP, strict sense stationary process can be what? WSSP, if but not vice versa. Right? Suppose x of t is what? Strict sense stationary process. It can be what? WSS process. But if x of t is following this condition, that is wide sense stationary process, there is no necessary to x of t which can hold the condition of this strict sense stationary process, but not vice versa, right? So I am telling you this x of t, if suppose your random process x of t, it can hold the condition for the strict sense stationary process if what the condition to be satisfied of this strict sense stationary process, that is what? Mean constant, and or x depends on what is the time difference, depends on the time difference. If xt hold these conditions, this x of t, the time random process, is also called as this strict sense stationary process, right? Now I am taking another notes. I am just giving you notes in other notes in the sense of what is the DC power average power and what is the AC power. So I am just x of t is what I'm just taking is what is stationary process, that is stationary process can hold all conditions. This is what stationary process. So what is the condition of this? Expectations of x of t is what this is what it gives the mean, that is what mu x is what mean. If this is what DC level, if you are this is if mu x square, it's give what the DC power, right? I'm talking about this autocorrelation. We will talk about this autocorrelation separately with what is the property of autocorrelation, right? Something like that. So what is the relation between this autocorrelation and power spectral density? We will talk about later separately. Right now, what is expectations of what x square? If you're putting this is what mean square value of random process x of t. This is what mean square random variable random process x of t is what it's give what total average, it's give the mean square value. So it's also we can also call as what total average power, and sigma x square can be written like that. Expectations of x of t square minus mu x square. This is denoted by this is what the AC power. And what about sigma x is what the RMS value, right? This is RMS value. So I just want to tell you this is what I just want to tell you, because I just want to talk about what is the DC power, what is the total average power, what is the AC power in terms of these notations, that is expressions in terms of mean square value, and what is the variance. Now we are going to discuss about next point is what correlation and convolution. Right, I'm just going to talk about what is the correlation and convolutions. As we know that what is the convolution is what it is used to find out, it is used to find out what response of the system. But this correlation is what it is used to find out similarity between two signals, right? This is the about that. This is suppose we have two signals which contains the impulse response h of t and what is the x of t. What is the response is what y of t is what h of t convolution of what x of t, right? What about this is what convolution? This is we can say that convolution What about the correlation? I'm just considering it what two random variable. I'm just considering it what x of x1t and x2t. These two signal, I just want to consider it to what is the correlation between them. What is the correlation between them? So we can say that we can find out what is the correlation between them, or x1 x2 is what tau is nothing but taking the integration is what x of t. This is what relation between this x1t and x2 t minus tau. Just integrate with respect to t, and the limit is what minus infinite to plus infinite, and correspondingly what is the response of this one. So we can say that what this response is what, as I'm just consider it what y of t. Y of t can be written like that, minus infinite to plus infinite, sorry, x1 tau and x2 t minus tau. Just integrate over d tau, and limit is what minus tau is limit from minus infinite to infinite plus infinite. You will get what, these two relation, right? These two relation. So we can say that this x1 so we can from the correlation we can find out the similarity between two signals, and this is what response of the two signals, right? So as so this response is what x1t convolution of x2t, right? This one is what, this one is, we can say that this is what, right? So this is what correlation between x1 and x2. Now next point is what, autocorrelation. I'm just taking it I'm just going to discuss about what is the autocorrelation, and let x of t is what, stationary process. We have to take into consideration stationary process. X of t is what, stationary process, right? That is what the autocorrelation is what, in autocorrelation is, it depends on the time differences, that is tau. Now it is autocorrelation is depends on the what, it's denoted by rxx tau. It's depend on the what is time differences, x of t. Let x of t is what, random process, right? So x of t, so tau, it can be written like, just if you're taking the what, minus infinite, x of t is what, random process. We have to determine what is the autocorrelation of x of t. Just take the integration from minus infinite to plus infinite, x of t minus tau over dt. Its limit is what, this one. So we can say that x of this is what, the autocorrelation, right? And also it can be what, it can like that, x of t just convolve with x of minus t. If you are convolving this is at, just putting value of t is equals to tau, you will get what, the auto correlation. That is what, if you are taking this one, you will get rxx tau, right? If you are taking this one, you will get rxx tau. That is what, autocorrelation, right? So we can say that this is the relation between the autocorrelation. So we can say that Rxx tau can be determined by the convolution just x of t convolved with x of minus t. Just putting t is equals to tau, you will get this autocorrelation. This is a simply relation between what is the convolution of and what is the autocorrelation relationship, right? So as so I'm just giving you example. I'm just taking a problems is what x of t, a signal x of t is what 0 to 1. This is time versus what x of t relation. To find out, this is the signals waveform of x of t. We have to find out what is the autocorrelation of this signals. Now simply for determine this one, simply we have to go for what x of t convolved with x of minus t, and just putting the value of x minus what, just putting the value of t is equals to minus tau, you will get what Rxx tau. So how do you get it? Let this one is the x of t. What about x of minus t? This is what minus 1, this is 1 0. If you are convolving this one, you will get, if a convolution of two signals with same width, if convolution of two pulse signal with same width, that is the 0 to 1 width will be same. So after resultant will be what the ramp signal. That is what limit is what limit will be minus 1 to 1, and will be, this is what you will get. This is putting the value of t is equals to tau. I'm just putting over here, so you will get this one autocorrelation. So you will get autocorrelation of by the using of the convolution, just what x of t taking the convolution of x of minus t, you will get this one. Now what is the property of Rx autocorrelation? So before I discuss the property of the autocorrelation, it can be Rxx tau is nothing but what minus infinite to plus infinite x of t. This is what x of t minus tau dd. T minus tau, it can be written like that, what expectations of x of t minus tau. This is what, this is also, so we can say that expectations of x of t and multiply with expectations of x t minus tau. You will get, if you are taking the expectations, you will get autocorrelation. So I'm just going to, what is the first property of autocorrelation is what, if or x minus tau, it will be Rxx tau. So we can say that it is even function, right? And Rxx 0, the minimum value of 0 is nothing but modulus of Rxx tau, right? And if you are talking about x of 0, the exact value is what expectations of x of t square. It's what, it's give the mean square value of x of t. Mean square value is nothing but what, the total average power. This is called as total average power. So if you are putting the tau is equals to 0, you will get, this is what mean square value right over here. If you are putting the value of tau, you will get if you're taking, how would you get it? What is the expectations of x square? If you're putting, this is what expectations of x of t minus tau. If you are putting tau is equals to 0, is you will get expectations of what? This one, x square, which give the what? The total average power. Right, now next point is what? We have discussed the autocorrelation. Now we will discuss the cross correlation. Cross correlation. It is what? Cross correlation. Suppose we have to consider it, x of t is two random process, x of t, and y of t is what? Two random process. Then cross correlation can be written like that. It is denoted by or xy tau. It is just equal to expectations of what? Expectations of xt what and y of t minus tau. Right, this, so in the form of this one you will get expectations of xt y t minus tau. This is what? This is your the cross correlation. This is cross correlation x y tau. Right, so now the property of correlation, cross correlation. What is the property of the cross correlation? Properties of r x y tau. The first property is what? R x y, if you are putting a minus tau, it has to be what? R y x tau, right? R x tau. If suppose over here r x y tau is what? Expectations of x of t minus tau, and sorry, expectations of y t minus tau. Right, if you are putting what happened, x of y, x of what? R x y minus tau, if you are putting, then it has to be what? Expectations of what? This is what? Expectations of xt y t minus t plus tau. That is what? T plus tau. You will get what? R y x tau. Right, so this is your, if you are, this is, you can say that if you are putting minus tau, you will get what? This is what? You can get this value, right? You will get. Now the second property of this cross correlation is what? R x y tau, if you are taking the modulation, is the maximum value of this one is maximum value of this one is what? Under root of what? Under root of just multiplication of r x x 0 and r y y 0. If you are putting the value of tau in this individual autocorrelation of x and y, just taking the under root, you will get the maximum value of the modulus of this x and y. And third property is what? Modulus of x and y can be equal to, just equal to half of this r x x 0 plus r y y 0. Right, so this is all about the property that we have discussed for the cross correlations of between x and y, right? So we can say that r x y tau is what? Expectations of x of t and expectation of x of t, y of t minus tau, right? This is the expectation of x of t, y minus tau. If random process x and x of t and y of t is what? Independent. It is what? Independent. Sorry. If x and y are what? Orthogonal. If x and y is orthogonal, that means the phase difference between x and y is maintained 90 degree, so the cross correlation will be 0. R x y tau will be 0. Now the next point is what? Next point is what? Autocovariance. Autocovariance is denoted by cxx tau, which is just equal to expectations of x of t minus mu x. Expectations of x minus t mu x, just multiply with what? X of t minus tau, x of t minus tau minus mu x. If you multiply, and you will get what is the expectations? You will get expectations of x tau x of t and multiply with x of t minus tau and minus mu x square, or we can say that this is what? Rxx. This is Rxx tau minus mu x square, right? Now next point is what? Next point, cross covariance. Cross co, it is what? Denoted by cxy tau, which is what? Cx tau is nothing but expectations of x of t minus mu x, the mean value of the random process x of t, multiply with what? Y of t minus tau minus mu of y. If you are taking the expectation value, you will get expectations of x of t, y of t minus tau and minus mu x minus mu y. So this is what? This is autocovariance. You can say that. So cxy is what? Cxx tau minus mu x mu x mu y. So this is your cross covariance in terms of autocovariance. Now if random process x of t and y of t is what? Independent, what will happen? Then we can say that expectations of x of t, y of t minus tau is what? Expectations of what? X of t, what? And y of t, this is what? Expectations of x of t, and multiply with expectations of y of t minus tau which is just equal to what? If you are taking this value, you will get, this is what, if you will get this one. So what will happen if you are putting so cross correlation, cross covariance can be Cxy is what, this is what, just putting those value, you will get this one is what, mu x and multiply with mu y. So this is what, this value will be 0. If cross covariance is 0, that means random process x and y of x of t, y of t is what, uncorrelated. And what about, and second point is what, this is the first point, second point is what, if rx y tau is 0, what is the meaning of that? This is the cross covariance. If it is 0, that means random process x of t and y of t is what, is orthogonal to each other. What is the meaning of orthogonal? That means it's maintained the 90 degrees phase shift. It's 90 degree phase shift to each other of random process x of t and y of t. Now next, if you are taking the graph of what, the autocorrelation versus tau is what, this is rxx tau. What happened if these value vary with respect to, just like that, I'm going to say that note for rxx tau. This is what for the autocorrelation of random process x of t. In this process, if tau increases, then rxx tau will decreases. For tau is equals to infinite, then rxx tau will be 0, tends to 0, right? So this random process, if the tau increases, this vary with respect to this tau. So this is what, the slowly fluctuating, slowly fluctuating, right? Slowly fluctuating random process x of t. What about this will happen? This is what, rapidly fluctuating of random process. This is what, rapidly fluctuated. This is rapidly fluctuating random process of x of t. Now we are going for the next heading is what, power spectral density. Power spectral density. It is also called as what, spectral density. Power is also called as spectral density. Right? It is denoted by, for what, random process. Let random process is what, random process x of t. It is denoted by SS xx of f, right? It is denoted by this one. It can be denoted by this one, right? xxf. In the frequency domain, it is a spectrum. The the power versus spectrum, we are going to analysis of the frequency versus the power. So this is the it's give the power per unit bandwidth. This is called as power spectral density, right? So if in terms of what is the omega radian per second, you will get, we can denotate this power spectral density is what, s x x omega, right? So if we are, so we have what, random process x of t is what, a random process, right? And what is the autocorrelation of x of t is what, I am just taking it, what, x of the autocorrelation of x of t is autocorrelation of x of t is what, I am just denoting it, what, x tau. If the frequency spectrum, if you are taking the Fourier transform of this autocorrelation, if you are taking the Fourier transform, that is what, r x tau multiplied with e to the power minus j 2 pi f tau d tau minus infinite to plus infinite. This is what, if you are taking the Fourier transform of this one, you will get what, x f, right? The Fourier transform of, we can say that the Fourier transform of this autocorrelation to give the what, this power spectral density. And what about if you are taking the inverse, r x tau, if you are taking this one, what will happen? If you are taking minus infinite to plus infinite, s x f e to the power j 2 pi f tau df, right? It can be also, if this the power spectral density, which is in the form of the frequency, if what then what happen if this power spectral density in the form of omega, if we have in the form of omega, what will happen? Then how do you get this power spectral density? This in, how do you get the inverse of this power spectral density is what, e to the power omega tau d omega, taking the integration of minus infinite to plus infinite, just divide by 1 upon 2 pi. So we can write this this autocorrelation in the form of the frequency, power spectral density in the form of frequency or omega. So we can say that this is this relationship is called as what, Wiener-Khinchin's relation. So this is, so simply the power spectral density is what, the frequency Fourier transform of autocorrelation. It's give the what, it's give the power spectral density. Note, what is a note? I'm just giving a note. If x of t is what, power signal, and or we can say that this is periodic signal. If periodic signal is, it is also power signal. If x of t, this random process, is power signal, then the spectrum which is associated of x of t is called as what, power spectral density. Power spectral density. What happened? This is the what happened if this signal, what happen if x of t is what? Energy signal. What happen if this one is energy signal, then spectrum will be what? Energy spectral density. Energy spectral density. So ESD and PSD. Frankly speaking, if our signal x of t is what? Energy signal, we can go to calculate the energy spectral density. If this x of t is what? Power signal or periodic signal, we can calculate the power spectral density, right? This is the meaning of this. So now the property of power spectral density. Properties of PSD. The first property is what? This is what? Real signals. Real. SXX of what? Is this real? And it is what? Real. Then what happened? It is non-negative value. Power is not negative value, so the value of this power spectral density, which is vary from 0 to infinity. We can say that this is non-negative. Right. So second property is what? SXXF. If you are taking minus, it is what? SXXF. This is what? It is the even signal. This is, so we can say that the power spectral density is what? Even signal. Third property is what? If you are taking the area under power spectral density, if you are taking the area SSF, if you are taking the area of power spectral density, this is minus infinite to plus infinite. It is what? It's give what? R XX0 is nothing but expectations of x square. This is what? It's give the what? Mean square value of x of t, which is nothing but total average power. Total average power, right? How do I get it? I'm just taking you know about that RXX tau can be written like that. If you are taking the inverse of minus infinite to plus infinite, S F e to the power what? E to the power minus j, sorry, e to the power plus j 2 pi f tau. This is what? df. If the value of, if the putting the tau is equals to 0, what will happen if at tau is equals to 0? That means minus infinite to plus infinite, SSF, it will be 0. This part will be 0. So it is what? df. What is the meaning of that? If you are taking area under the power spectral density, if you are taking the area under this PSD, area under PSD gives what is the power, that is what? Total power of, this is what? Total average power. It gives the area under power spectral density, gives the power, right? So this is the meaning of that. If you're putting value tau is was tau x of if you are autocorrelation at t equals to 0, tau equals to 0, it's give the what? Expectations of x t square, x square tau t. It is nothing but mean square value of x of t. This is what? Total average power. Ultimately, I'm trying to say that the area under probability density functions, give the total average power, right? So this is all about what we have discussed, power spectral density, and what is the property of this power spectral density, right? Now the next point is what? The transmission of random process over LTI system. Over LTI systems, we have a LTI systems, then we have to find out what is the condition of the random process over LTI system, transmission of random process over LTI systems, right? Suppose we have a LTI system, linear time invariant system, and response of this system is what I am just denoting it y of t, and input is what x of t, and impulse response is h of t. So we can say that y of t is nothing but convolution of h of t of x of t, right? That y of t is nothing but h of t convolution of x of t. We have to check it out. What is the conditions? The main motive for the transmission of the random process over LTI system. What is the conditions of y of t? What is the condition of y of t is to be what w is to be what WSS for given x of t random process. For given random process x of t, what is the condition of y of t is to be what white sense stationary process. We have to check it out. What is the conditions of y of t to be stationary, to be white sense stationary process? Now let's check it out. So first we have to know about that if mean of this value, if we know mean of this random process, which y of t will be constant. So we can say that y of t is what? The first condition follow for WSS. If mean of what? The first condition is what? Y of t is to be what? Y of t is to be WSS process. Then what about the mean square? The expectations of y of t is what? It should be what? The constant. It should be the constant h mu y. This is constant. And the second condition has to be satisfied, has to be hold. This is what? If autocorrelation of what? Y of t is t1 comma t2. I'm just taking it two point of time. This is t1 and t2. It's depend on what? It's depend on what? The time difference. That is what? t2 minus t1. Now let's check it out. The first condition is what? We have to show that y of t, the mean of the y of t has to be constant, and the autocorrelation of y of t is what? It's what? Depends on what? The time difference. Right. Now I just want to check it out. Now what will happen? Y of t is what? Y of t is what? H of t convolve with what? X of t. So we can say that I'm just taking the tau 1 is for convolution, taking the tau 1 for convolution. So we can say that h of tau 1 x of t minus tau 1 is what? D tau 1. This is what? Y of t. This is y of t. If you are taking the integration from minus infinite to plus infinite, then what will happen? Expectations of y of t is nothing but expectations of this one, minus infinite to plus infinite, h of tau 1 and x of t minus tau 1 d tau 1, right? So so it can be written like that, minus infinite to plus infinite, h of tau 1 expectations of what? X of t minus tau 1 and d tau 1. This is what? Expectations of ht. So what will happen? This is what? Expectations of x of t minus tau. This, if this one is the constant, if this constant, if x of t, the expectations of x of t is constant, then ultimately you will get the expectations of y of t is also constant, because it's depend on the expectations of x of t. For the constant, so we can say that if this x of t, the expectations of x of t is what? Constant, that is what? Mu x. If the expectations of x t minus tau is what? It's is constant, that is independent of the time. So we can say that this expectations of y of t is what? It's independent of the time. So we can say that minus infinite to plus infinite, h of this one and d tau, and it is a constant. It can be came out of this integer mu x. So the first condition is going to follow. What is the condition of that? So expectations of y t is nothing but mu x for what? X of t should have what? WSS process. If this one x of t is what? WSS process, then the expectations of x of t is what? Mu x, which is constant. This is what? Minus infinite to plus infinite, h of tau 1 d tau 1 d tau 1. It is what? If you add e to the power, so we can say that this one can be written like that. This whole things can be what? It whole can be mu x h of f. This is for f is equals to 0. If you are putting the value of f is equals to 0, you will get what? Mu x h of 0. The 0 at the 0 frequency. What is the expectations of what? Y of t. You will get expectations of y of t is what? Mu of x h of 0. This is the first condition. This is satisfied. For the y of t is what? WSS process. If it can be only, it can be if x of t is what? White sense is stationary process, that is the mean. If expectations of x of t is what? The constant. Now second property, second condition, it has to be follow that y of t is to be WSS process. Now second condition is what? Let t1 is what? y1 is t1, this random variable y of t1, and for t2 it is what? Y of t2. You will get, I am for taking the convolution of what? For convolution t1 and t2, I am using tau 1 and tau 2 for the convolutions, right? So we have to determine what is the autocorrelation of what? T1 and T2. If this depends on the time differences, if the autocorrelation of y of t depends on the time differences, that means this y of t is what? Satisfy the second condition. First condition is already satisfying. For x of t, is what white sense stationary process. So now we are going to calculate what is the autocorrelation of y of t at t1 and t2. This is what now it can be written as what is the autocorrelation of y of t is nothing but expectations of y t1 and y of t2. How do you get what is the expectations of t1? It is nothing but expectations of, it is nothing but, how do you get it? Minus infinite to plus infinite h of tau 1 x t1, I'm just considering it t1 minus tau 1 d tau 1. What about this one? This one is what? Minus infinite to plus infinite h of tau x of t minus t2 minus tau 2 d tau, right? I just want to expectations of the whole integrations, right? So it can be written like that, expectations of what? Minus infinite to plus infinite h of tau 1 and h of tau 2. This is what? X of t1 minus tau 1, what? T1 minus tau 1 and what? X t2 minus tau 2. This is what we have to find out, and because this is the constant, it's constant, so expectations is only performed in the time, so it can be written like that, minus infinite to plus infinite h of tau 1 h of tau 2, sorry, we have to t1 t2 and t1, what is the this is what? D tau 1 and d tau 2, right? D tau 1 d tau 2, d tau 1 d tau 2, and it is nothing but we can perform on this x of tau 1 minus t1 minus tau 1 and x is what? t2 minus tau 2. This is what? Tau 1 and tau 2, right? So this is what? r y t1 comma t2, right? So this is what? This is the time instant is what? I'm just taking it what? t1 and it is for t2, two expectations, that is what? It can be written like that. So expectations of x of t1 and expectations of t2 is what? If x of t is what? If x of t is WSS process, then the autocorrelation of x of t, this is what? X of t, the autocorrelation of x of t, if x of t is what? If x of t WSS, that means it has to be follow the autocorrelation must be the time difference, must be depends on the time difference. So we can say that this rxx tau can be rxx tau, sorry, t1 comma t2 can be written as what? It's depend on the time difference, that is what? rxx t2, this is capital T2 minus t1, right? For x of t is to be WSS process, right? So I am just putting it, so we can say that I am just putting it this whole terms in the form of this one. So we can say that expectation, this is rxx, this is what? rxx t2, this one is t2 t2 minus tau 2 minus this one is what, t1 plus tau 1, t1 minus tau 1. What will happen if you are taking this one, h of tau 1, h of tau 2, d tau 1, d tau, just taking the minus infinite to plus infinite. This is what r y of t1 minus t2, t1 comma t2. This is what, if rx is what, WSS process, it has to be follow this one. So we can say that, so it can be what, r y of t1 minus t1 comma t2 can be written as minus infinite to plus infinite, h of tau 1, h of tau 1 and h of tau 2. This is what, rxx, we can say that it will be t2 minus t1. So we can say that t2 minus t1 is what, plus tau 1 minus tau 2. This is what, d tau 1, d tau 2. So we can say that this is t2 minus t1, t2 minus so we can say that this is what depends on that, this time difference depends on time difference. So we can say that this is what, WSS process. So t2 minus t1 can be, I'm just putting it, is tau. So it's depend on what, so rxx tau plus tau 1 minus tau 2. So it's depend on what, this value, it is depend upon the difference of x of t. So we can say that y of t is what, if you are transmitting x of t over LTI system, for y of t 2 is to be WSS process. If x of t, the input should have what, it follow WSS process. If x of t is WSS process, y of t is also WSS process, right? I am already so this is, I am just proof this one by the using of the mean value, what is the autocorrelation of the y of t, it's depend on the this one. Now, and over LTI system, what is the power spectral density of the output? H of t is the impulse response, y of t is what, the response of the system, x of t is what, input signal. So what is the power spectral density of the y output? So PSD. So next point is what, PSD of LTI. PSD of LTI system. So y of t is nothing but h of t convolution of h of t and x of t, right? If you are taking the Fourier transform, so we can say that y of f, h of f, x of f, the time domain convolution, the frequency domain multiplication. So if you are squaring both sides, what will happen? They are taking squaring of the both side. Y of is what, taking the modulus and squaring the both side of h of, this is what it can be written like that. right? So we have equations. Equation number 1, h of y of f square is what? Nothing but just multiplication of individual response, the frequency response of h of and x of input response, just multiplication of, just multiply this value, you will get this one. Now x of t is what? The autocorrelation of x of t is what? X tau, which is nothing but x of t convolution of x of minus t. So taking the convolution of x of t and x of minus t, you will get the autocorrelation of x of t. This is the autocorrelation of x of t. So if you are taking the Fourier transform, you will get what? X of f multiplied with x of minus f. This is what, if you are taking the Fourier transform of the autocorrelation, it gives the power spectral density. That is what? X f. This is the PSD of x of PSD of random x, PSD of the input signal x of t, right? X of t, what is the PSD? So PSD of x of t is what? I have denoted it what? This one, which is nothing but this one. So if x of t is what? Real, if xt is what? Real signal, then what is the Fourier transform of x of t? Fourier transform of x of t is what? X of, and what is the Fourier transform of is what? Minus t. What is the Fourier transform of minus t? It is what? X of minus f. So we can say that it is what? X conjugate of f. If xt is what? Real, right? Let x of f is what? 1 plus j. X of minus f is what? 1 minus j. And x of conjugate of f is what? 1 minus j. So if x of f conjugate x of conjugate of x of f, it is what? It is nothing but just modulus. It's give the modulus. This is what? 2. So we can say that this can be written like that: x of f multiply with x conjugate f, this one, and it is what? X of, it can be, it is what? X modulus, it is modulus x of f a whole square. So we can say that this is what? So this is what? This is, so this is can be written as what? S f. This is what? PSD of, this is the PSD of input. And similarly we can say that this is can be written as what? S y of this is what? PSD of output. So if we have a system, LTI system, if we have LTI system, if it response is, if the PSD output PSD, it's give the output PSD and x PSD of input h of, then how do we get it? The PSD of output is nothing but h of modulus of h of square the PSD of input. So this is very important, you know, this is very important relationship of the PSD of the input and PSD of the output, right? You can, if we will get, if for given the PSD of the input, we can find out what is the PSD of the output. So if you are taking the area under PSD of output, df minus infinite to plus infinite, it is what? This is r y by tau, which is, it's give the total power. Now I am taking a problems. Problem is what? The first problem, x of t is what? Random process. X of t is what? ESE cos 2 pi f c t plus theta, right? And this is random process. This is random process x of t, which is just equal to ESE cos 2 pi f c t plus 5 plus theta, where ESE and what? FC is what? Or constant, and this theta is uniformly distributed over minus pi to pi. Then find out first is what is the autocorrelation function of x of t, that is what? Rx tau. And second problem is what is the PSD of x of t, that is what? S, I'm just denoting it what? S x of f. These two things that we have to find out of this random process, right? Now let's solve it. X of t is what? ESE cos 2 pi f c t plus theta, where theta is uniformly distributed. So we can say that if you are taking the PDF, what is the PDF? Minus pi to pi, it is uniformly distributed over minus pi to pi, and this is what? Theta, and this is what? The PDF of this theta. This is what? 1 upon 2 pi. So we just take we just make a diagram of this theta, the PDF of this theta. We will get this kind of, because this is uniformly distributed over minus pi to 2 pi, minus pi to pi, right? So this is the equation that has been given in this particular questions. Now we need to find out what is the autocorrelation of x of t. So how can you get it? You know about that. Autocorrelation of x of tau is what? Expectations of x of t and x of t minus tau, and the x of t is what? A stationary process. We have to assume it because the autocorrelations depends on the time difference. So this is what? A stationary process. Right, this is, if x is stationary for process, then autocorrelation depends on the time difference. So x of t is nothing but expectations of x of t multiplied with x of t minus tau. Just putting those values, x of t is what? ESE cos 2 pi f c t, and what? X of t minus tau, we can written like that, just multiplication of ESE cos 2 pi fc t minus tau, sorry, theta we have to, sorry, I forget the theta, so theta t minus tau plus theta. This is what expectations of this. So I'm just putting over here, just it's of this is what. So as you know that if you multiply with 2 and divide by 2, what will happen? Then AC square, it will be, because it is a constant, as according to the problems this AC and FC is a constant, so we can say that AC square by 2 will be just came out from this expectations value, and we can say that this multiply with expectations of what, 2 and 2, cos 2 and 2 we can written like that, what, cos 2 pi f ct plus this one a plus b, cos 2 pi f ct plus what, 2 pi f fc t minus tau, sorry, plus phi plus theta, 2 pi fct t minus tau plus theta, and plus and minus a minus b, cos 2 pi fct plus phi theta minus this one minus b, minus 2 pi f c t minus tau minus theta minus theta. This is what, this is whole expectations value. As you know that if you have plus this one, what will happen? So this is going to be AC squared divided by 2 expectations of what, cos 2 pi 4 pi fct, and if you are multiplying this one, you will get what, minus 2 pi f c tau plus 2 theta. This is what, and plus this one is what, taking this one negative, you will get, it will be cancelled, and it is also cancelled over here. You will get cos 2 pi f c tau, right? As you know that this expectations is a linear operator, so we can say that AC square divided by 2 expectations of what, cos 4 pi f ct minus 2 pi f c tau plus what, 2 theta. This is what, this one, and plus what, I'm just multiplying it over here, AC square divided by 2 expectations of this one is what, cos 2 pi f c tau. This is what, this, because this fc is a constant, tau is also constant, so this term can be written as what, this term can be written as AC square divided by 2, this is what, cos 2 pi fc tau, this equation. And what about this one? This can be, I'm just taking it over here, these terms can be written, this is what, if you are taking the area under this expectations value is what, it's been defined is what, AC square divided by 2, and what, we have to find out what is the expectations of this one, and also the theta, the PDF of theta has been given, so we can say that then g minus pi to pi, this expectations value, this is what, cos 4 pi f ct minus 2 pi f ct tau plus 2 theta, and multiply with this PDF. This PDF is what? 1 upon 2 pi over d theta. Because you know about that, if you are taking if you are taking the area of a complete cycle, that is minus pi to 2 pi, it's whether it's come from the cos signal or sine signal, it's always give the 0. So these terms will be 0. So we can say that these are expectations of x of t. So autocorrelation x of tau is what? AC square divided by 2 cos 2 pi fc tau. So this is our what? Autocorrelation. Right. Now we have to find out, second part is what? We have to find out what is the power spectral density of x of t. Power spectral density can be what? If you are taking the Fourier transform of what? Rxx tau d Rxx tau, if you are taking the Fourier transform of the autocorrelation e to the power minus j2 pi f tau d tau, you will get what? This is what? Power spectral density PSD of x of t. How would you get it? As you know that we have to find out what is the, so AC square divided by 2, this is what? Cos 2 pi fc tau, this is what? Rxx tau, and it can be written as AC square divided by 2 in the form of exponential carrier e to the power j 2 pi fc tau plus e to the power minus j 2 pi fc tau divided by 2. So we can say that Rxx tau can be written as AC divided by 4 is what? E to the power j 2 pi fc tau minus e to the power plus e to the power j 2 pi fc tau, right? If you are taking the Fourier, we have to go for the Fourier transform of this one. As you know, the exponential Fourier, if you are taking the Fourier transform of this exponential carriers, you will get what? AC square. It's give what? It's give the impulse function, that is what? Delta f minus fc plus delta f minus fc plus delta f plus fc, right? So this is your, so we can say that this is what? S x f. So our PDF is what? You will get this one. So if your graph, if you want to take the graph of what is the frequency versus this power spectral density graph, what will happen? At this you have two frequency component, that is first frequency component is what? Minus fc, second one is fc. At this instant the impulse in the area under this one is what? AC square divided by 4, then strength is also same, AC square divided by 4. This is your what? The power spectral density of random process x of t, right? Now we suppose next point is what? Mixing. Suppose I'm just going to mix a random process with another sinusoidal random process, just like that. So next heading is what? mixing of random process with sinusoidal process, right? I am just going to mix a random process with a sinusoidal process. So we can say that just multiply with this one is what x of t, and autocorrelation of x of t is what rx x tau. I am going to mix it what this is what AC cos 2 pi fc t plus theta, right? I'm just going to mix it AC cos 2 pi fc t plus theta, right? And you will get, after mixing it, yt. You have to find out this at this output. This is autocorrelation of yt, new random process, and second is what we have to find out what is the PSD of this one. So as you know that I am just taking into consideration is what AC, where AC and FC is what constant, and this theta value is what uniformly distributed over what minus pi to pi. It is uniformly distributed over this one. So how do you get it? How do you solve this one? So it is uniformly distributed, that means it is what the PDF of is vary from minus pi to pi. This is theta. What is the PDF of this theta value? This is what f of, so this is the PDF of theta, right? So how do you get it? Now after what, after multiplication of yt is nothing but just x of t, you will get AC cos 2 pi fc t plus this theta value. This is yt. So what about autocorrelation of what of yt is nothing but expectations of what yt multiplied with yt minus tau. And you can also write like that. It can be also expectations of yt multiplied with yt plus tau. Both are same. So I'm just taking it what this part. So expectations of what, expectations of yt is what x of t multiplied with AC cos 2 pi fct plus theta, right? This is what expectations of x of y of t, and just what is the value of yt minus tau, just multiply with what is the value of t minus tau, that is ft minus tau, and AC cos 2 pi fc t minus tau, and plus t minus tau plus theta. So this is what this one, and this is whole expectations. As you know that this AC square, this is the constant with respect to this random process. So I'm just multiply with 2 and divide by 2. This whole AC square will be just came out from this expectations. So we can say that r y tau can be written as AC square divided by tau, and expectations of what? X of t minus tau. I'm just taking this one, x of t minus, just separate, and this one is what? This, and this we have to solve it. Just multiply with, you will get what? You will get what? Cos 2 pi fc t plus theta, and plus 2 pi fc t minus tau plus what? Theta, this one and this one, this and this, a plus b, right? And what about a minus? What about a minus? This is your a, this is what? A plus b. And what about a minus b? This is, so we can say that minus cos 2 pi fct, and minus 2 pi fc t minus tau, sorry, plus phi minus t minus this one. So we can say that AC square divided by 2, expectation is a linear operator, and what is, so we can say that expectations of what? X of t minus tau, this is what? You will get what? Cos 4 pi fct minus, sorry, cos 2 pi fct minus 2 pi fct tau, and 2 theta, this one, and plus, sorry, it will be plus plus this one cancel, you will get theta is also cancel, so you will get cos 2 pi fc tau. So I am just taking the inner, I'm just taking expectations of inner part of this one, so this is, and multiply with this one, so we can say that AC square divided by 2, expectations of x of t minus tau, this is what, and this is what? Cos 2 pi fct minus 2 pi fct tau plus 2 theta, plus just multiply with this one, so we'll get AC square divided by 2, this is what? Expectations of x of t minus tau, and multiply with what? Cos 2 pi fc tau. So this will cancel, it will be 0, this part will be 0, because you are taking a complete area under complete circle, that is minus pi to pi, because 2 theta is in the PDF of 2 theta has been given, so this part will be 0, so you will get this part. So we can say that autocorrelation of y tau is what? This is the constant, this one is the constant, so because there is no term, there is no any terms of the t, so we can say that this came out AC square divided by 2 cos 2 pi fc tau, and this is what? Multiply with expectations of xt minus tau, this is what? These expectations can be written as what? Expectation, this is autocorrelation part, this is autocorrelation of what? This is autocorrelation, this is autocorrelation of x of t, this is what, so we can say that the autocorrelation of autocorrelation of y of t is nothing but AC square divided by 2 cos 2 pi f c t and multiply with r x x tau. So what is your conclusion? Conclusion is that, so this equation can be written like that, can also be written as x x tau r x x tau multiply with AC square divided by 2 cos 2 pi f c tau. You are multiplying with, this is your x of t and this is what, AC cos 2 pi f c t plus this theta value, and yt is nothing but just multiplication of x of t and this sinusoidal signals. Then after the autocorrelation of x of t is what, xf tau, and this is, and autocorrelation of this is what, AC square divided by 2 cos 2 pi f c tau plus, sorry, this one is what, autocorrelation of this sinusoidal signal process. So we can say that after getting multiplication in the time domain, then after output after resultant autocorrelation will be just multiplication of the individual autocorrelations. So we can take a note is what, just put in notes, if multiplication in the time domain, multiplication in time domain this corresponds to the what, corresponds to the multiplication of in what, corresponds to the multiplication of individual autocorrelation. I'm just so you have already get what is the autocorrelation is what, rxx what, rxx tau multiply with what, AC square divided by 2 cos 2 pi f c tau. This is what, output of the autocorrelation. Now we have to find out what is the power spectral density. What is the power spectral density of this output, corresponding output, what we have get? So the Fourier transform of this one, you will get the power spectral density of the output. So power spectral density, you have, this is what, x of t, the time domain multiplication correspond to the frequency domain convolution. So you will get what, this one, what is the Fourier transform of this one? I have already talked about what is the Fourier transform of this one. This is what, delta function f minus fc plus delta of what, f plus fc. So after convolution, what you get, this is what, AC square divided by 4, this the PSD of the x of t is just shifted minus fc plus f of, So this is what, so this is your, this is your, what is the PSD of what is the output. So how do you make it? That is what at this instant FC your, suppose your power spectral density is what, x of t, it's correspondingly it's shifted minus FC. Suppose R will be just like that, minus this is what our x f power spectral density of the x of t. This is minus omega, this one is the plus omega, right, which is in the form of f. So it is just shifted to the left by FC and right by FC. At this instant the FC is what, FC at this instant minus FC. So you will get what, at this instant it will just shift it. So you will get what, FC plus W. This one is what, FC minus W. This is what, power spectral density of SYYF. This is what, FC minus FC plus W, and this instant minus FC minus W, and strength will be what, this is what, AC squared divided by 4. So this is your power spectral density of output, right? Now moving for the next point is what, white noise. White noise. White noise. Suppose a random process x of t is said to be what, white noise. If the PSD, if the power spectral density of x of t, if PSD of x of t is constant for all value of frequency. So we can say that if suppose our power spectral density is what, F, this is white noise power spectral density of PSD, I am just denoting is what, S for white noise, I'm just denoting it what, S N N F, and it is a uniform constant. This is what, n by 2, this is what, it is a parameter. So we can say that for this power spectral density of white noise is what, n by 2, neta by 2, this is the neta by 2 for all frequency, right, and the value of this one is what, watt, and unit of this one is what, unit of this one is what, watt per hertz, right, per unit bandwidth. It's give the power per unit bandwidth. So we can say that it's provide uniformly, it's provide for constant power spectral density for all the frequency. Suppose if you are for over all frequency band. So this is the meaning of the white noise. This is the meaning of the white noise. It's provide a constant power spectral density throughout the bands, right? So if you are taking this one, if you are taking what, the autocorrelation of this one, if you are taking this one, what you get, this is what, delta functions, this is n by 2 sigma f, because if you are taking a constant if you are taking the inverse Fourier transform of a constant spectrum, you will get this one. So we can say that it can be written as what, it can be, this is tau, this is what, Rn tau. At this instant is neta by 2 at tau is equals to 0. Area is what, area will be this one. So this is all about white noise that we have discussed. Note, as you know that the PDF of white noise is Gaussian in nature. PDF of white noise is Gaussian in nature. So we can say that white noise is also called as white noise is also called as what, Gaussian noise, right? So generally we are taking into consideration white noise. The mean value of this white noise is what, 0 mean. Generally we are taking the mean will be what, 0 mean. So PDF can be draw this one. This is what, x 0 mean. So 1 upon, so this is f of x can be written as 1 upon 2 pi e to the power 2 pi under root 2 pi sigma square. This can be written as what, the PDF of what, PDF of f of x is nothing but 1 upon 2 pi sigma square e to the power x square divided by 2 sigma square. At this instant the value of this PDF will be what, at this instant PDF is what, 1 upon under root 2 pi sigma square. So because the PDF of white noise, the PDF of white noise is Gaussian in nature, right? So next point is what, next note is what, PDF of white noise, PDF of white noise, PDF of white noise, Gaussian in nature. That we have already discussed this one, right? So thank you so much for all for watching me, because I have this, in this session we have discussed the complete random process, right? In the next video lecture I would like to teach I would like to discuss some important questions, right? So thank you so much for watching me.